Assalamualaikum warahmatullahi wabarakatuh, and very good morning. Today we will analyze the forces in each members of the given truss structure and determine whether they are in tension or compression. For the first step, we need to identify the given data. We are given a simply supported truss with external load of 50 kN applied at point L, K and J. The total span of the truss is 6 sections of 3 meters each, and the height is 4 meters. Our goal is to determine the forces in the truss members. Second step, we need to calculate support reaction. So using the sum of moment at A, we assume clockwise is positive. We do moment at point A. Sum of moment A equal to 0. To solve GY, we need to set up the moment equation. 50 times 1 plus 50 times 2 plus 50 times 3 minus G is times 6 equal to 0. So we get the G is 50 kilonewton. Next, using the sum of force in the vertical direction. So we assume to the right is positive. Sum of Fx is 0. Ax equal to 0. Okay, now sum of Fy. We assume up is positive. So sum of Fy is equal to 0. Ay minus 50 minus 50 minus 50 plus 50 equal to 0. So we get Ay 100 kilonewton.
Next, we need to identify which three members are in tension or compression for FLK, FLD, and FCD. The calculation of FCD. We assume clockwise is positive. Moment of L equal to 0. FCD times 4 minus 50 times 1 plus 100 times 2 equal to 0. FCD equal to negative 150 divided by 4, we will get negative 37.5 kilonewton, which is FCD are in compression. Next, for FLD, we assume upwards is positive. So negative FLD sin 45 plus 100 minus 50 minus 50 equal to 0. Next, for FLK, clockwise is positive, moment of O. Negative FLK times 4 minus 100 times 3 plus 30 times 1 plus 50 times 2 equal to 0. FLK equal to 37.5 kilonewton is in tension. Next, we assume to the right side is positive. Fx equal to 0. FLO plus FLK plus FLD cos 45 equal to 0. And we'll get negative 37.5 plus 37.5 plus FLD cos 45 equal to 0. FLK, FMN, FML, FKJ, FJI, FIH are 37.5 N. And members for FCD, FAB, FBC, FDF, FEF, and FFG is negative 37.5 Newton.
For second question, from the diagram given, first of all, we need to draw the FBD, free body diagram. We need to include the force that involved. At point B, we have By and Bx. At point D, we have dy, and then force P that is equal to 480. And then from the free body diagram, we need to write down the equation. First, we need to find the moment at B, and I assume clockwise is positive. And moment for P, we have dy multiplied by the distance 12, and then minus by 480 multiplied by 8 equal to 0. And then we get dy equal to 320 Newton. After that, we need to find the Fx. Write down the equation. I assume positive is to the right. Fx equal to 0. And at Fx, we have P that is equal to 480 plus Bx equal to 0. And then we get Bx equal to negative 488 Newton. Because our assume is wrong, then we need to change the direction. And then we need to find Fy. I assume that net positive is going up, then Fy equal to 0. At Fy, we have dy plus by. Because we already get the dy is equal to 320 plus by equal to 0. And then by equal to negative 320 Newton. Because our assume is wrong, we need to change the direction going down.
For the next part, we have to draw the FBD for the second section. Then we have to find moment for the whole FBD. So I assume clockwise is positive. Sum of moment at point A equivalent to 0. 320 times by 20, the distance, minus by C times 16, the distance, minus by 480 times 4, and minus 320 times 8 equivalent to 0. We'll get C at 1920, divide by 16, we'll get 120 newtons. For horizontal forces, sum for Fx, we assume to the right is positive. We'll have Ax minus 480 equivalent to 0. So Ax equivalent to 480. For the vertical forces, we assume upright is positive. So sum of Fy equivalent to 0. 320 minus 320 plus Ay minus 120 is equivalent to 0. We'll get Ay is equivalent to 120. After that, you'll have to find the resultant force for each component. We'll have A square root of 120 square plus 480 square will get 494.77 newtons. For component B, we will have square 320 squared plus 480 squared equals to 576.89 newtons. In conclusion, we have A as 494.77, B 576.89, C 120, and D at 320 newtons.
For the next question, number 3, determine the force P at the exit on the twig at E. Okay, first of all, we must divide by 2 our picture to upper part and lower part. For the calculation, we assume that to the left is positive, so sum MB equals 0. 100 Newton times 11.88 minus AY. 11.88 because we convert the length of 108.75 mm to 11.88 cm. Okay. So AY equal 1188 Newton. Sum MA equals 0. 100 Newton times 13.76 plus BY equals 0. BY equal minus 1376. So when we define the MA and MB, we can put it in the equation. Sum MA equals 0 is 100 times 13.76 minus BC 0.832 times 1.25 cm for the X minus BC 0.555 times 1.88 cm for the Y axis equals 0. So total is 1376 minus BC 1.04 minus BC 1.0434 equals 0. So the final answer is BC is 660.46. Okay, now for the upper part, we consume that the to the right is positive, so sum MO equal to 0. So negative 660.46 times 0.832 times 3.75. 3.75 we get from the picture, which is 37.5 mm. We convert to cm. Okay, next. Minus 660.46 times 0.555 times 1.25. Also, we convert from the picture FP times 2.5. 2.5 we get from the length of FP to dy, so equal to 0. Next, the answer is FP equal to 2518.79. Then we divide to 2.5, so the final answer is 1007.52 Newton. So the force the exert on the twig at E is 1007.52 Newton.